Hello everyone, how are you? In this video, we are start chapter number 9 Mechanical Properties of Fluids, topic Bernoulli Theorem. And this topic is very important from your examination point of view. This derivation, the question comes in your exam like that: state and derive Bernoulli theorem in up to 4 to 5 marks. So it is very important. So what is the statement of Bernoulli theorem? We write a question: state and derive Bernoulli theorem. The Bernoulli theorem has several names like Bernoulli principle, Bernoulli equation, Bernoulli law. So this is have several names. Now solution. First is statement. What is the statement? When a liquid flows through a varying cross sectional area tube, the energies, that is kinetic energy, potential energy, and pressure energy, remains constant, that is P plus half rho V square plus rho G H is equals to constant. We prove this equation, and this is the Bernoulli equation. This equation now we derive. Now proof. Consider a cross sectional area tube that is the liquid flows via velocity v1 and pass out through velocity v2. The area of if big area is a1 and small is a2, the change in velocities v1 delta t and here v2 delta t. This tube is at a height from the ground. This is h1, this is h2, this is the ground. Here the pressure is exerted P1 and P2 from the cross sectional area. Now prove. First of all, we find the mass of both big and small tubes. Mass is equals to volume multiplied by density. So this volume is density of the liquid is same, rho multiplied volume is A1 V1 delta T. Let equation number 1. This is M1. Now similarly M2 is equals to rho A2 V2 delta T. Equation number 2. Now we find change in kinetic energy. Change in kinetic energy is equals to 1 upon 2 1 upon 2 half m v2 square minus 1 upon 2 half m v1 square. This is, take the half m is common, half m common inside, v2 square minus v1 square. This is, it is equation number 3. Now we find change in potential energy also. This is delta K. Change in potential energy, the formula is mgh. The here h is h1 and h2 both, so mg h2 minus mg h1. Mg is common inside, h2 minus h1, it is change in potential energy. Equation number 4. Now pressure is also exerted. Now we find the change in pressure energy. Change in pressure energy is equals to P1 into A1 V1 delta T minus P2 A2 V2 delta T. Now add equation 3 and 4 and equate with fifth. This is fifth equation. Add equation third and fourth, equate with fifth. Fifth, that is P1 A1 V1 delta T. We take this is on RHS P2 A2 V2 delta T plus half m V2 square minus V1 square plus mg h2 minus h1. This is, now according to equation of continuity, A1 V1 is equals to A2 V2, or it is equal to volume. So this is, so therefore P P1 delta T is equals to P2 delta T plus P2 delta T plus 1 by 2. Here M is, V is divided by this V2 square minus V1 square plus mg divided by m h2 minus h1. This is, now take the similar values from one side, that is P1 delta T minus P2 delta T is equals to 1 by 2. The m divided by v is density. The density is mass into upon volume. It is density rho. This is, the volume is same, so this is also a v2 square, and this is here also rho g. The height is, now height is same, so this is h. Now take it is from here, so p21 minus p2 is common, delta t is equals to 1 by 2 rho v2 square plus rho gh. Now you see that the delta t and delta t can be neglected because it is very small values, so we not need to write it is. So pressure P1 minus P2, this is coming there, plus half rho V2 square only V plus rho GH is equals to 0. The P is change in pressure energy is P, and it is half rho V square plus rho GH is equals to constant. So this is the complete derivation of Bernoulli theorem. Please take the screenshot of it. That is this also. So be practice it, and it is very important. Practice is again and again. So thank you everyone.